Right. I welcome you all, our dear viewers. I'm Mr. Hyper. I'm taking you through this topic. This time round, the topic is physical, or one can call it phase, equilibria, and this is the lesson 1 of this topic. Now, here in this heading are very important statements, very important words, which I think most of us might have heard about them before. The first one is physical, or what we call phase. Another word is equilibria. Now, we shall look at what physical equilibria deals with, or what it is concerned with. We shall look at what a phase is, and we shall look at equilibria itself means what. Equilibria is the plural form of equilibrium, meaning when the equilibrium established is more than one, it's no longer equilibrium, but equilibria. When we say physical, we're trying to bring in the effect of states of matter, phase. You're looking at those physical states of matter. So when we say phase equilibria, we're trying to look at the study, or we shall be studying the behavior of substances as they change phase. In other words, physical equilibria deals with the study of substances as they change phase. As they change phase. But we know that we've got solid, liquid, and gaseous state, right? So those are called the physical states. So when we talk about the physical states, right? When we talk about the physical states, simply think about solid state, liquid state, and then gaseous state. So these are states of matter, and they are known as states of matter because they are chemically indistinguishable. Now, when we say physical equilibrium, now first, let's look at equilibrium. A physical equilibrium, by definition, when we say physical equilibrium, when I say at equilibrium, that is at balancing point. So when we say physical equilibrium, we are at the state of balancing. So a physical equilibrium is that equilibrium established, or is the balance that is established, but is an equilibrium established between molecules of a substance, between molecules of a substance in one physical state and molecules of the same substance in another physical state. Equilibrium established between molecules of a substance in one physical state and molecules of the substance and molecules of the same substance. That substance should keep the same. Molecules of the same substance in another physical state. So what does it mean? It means that you can have a solid going to liquid and vice versa. So when a solid goes to liquid, it means that it was a solid in that physical state, but that very same solid is the one maybe that undergoes melting to go to liquid. So for example here, so this is called solid liquid equilibrium. This is called solid liquid equilibrium. E.g., one can look at ice liquid water equilibrium. Ice liquid water equilibrium. Then also one can talk about liquid vapor equilibrium. Liquid vapor equilibrium. Meaning here, the liquid establishes equilibrium with the vapor, but that same the liquid is one that went to vapor. So they are molecules of the same substances. Okay, e.g., one can consider liquid water and steam. Liquid water steam equilibrium. So we say that this is the equilibrium that has been established between the liquid and vapor. Then we also have solid vapor equilibrium. Solid vapor equilibrium. A solid going to vapor or a vapor going to solid. It means that they are components of the same state, but changing to different, they are substances. They are same substances, but going to different states of matter. So now, here you can consider maybe ice and steam equilibrium. Ice steam equilibrium. Now, for ice steam equilibrium, you can realize that this is a solid and this is a gaseous form, meaning that maybe you have heated a solid, it has gone to steam, and the steam has been, the steam also comes back to this side. Now, that is what we call solid vapor equilibrium. So all these equilibria are looked at differently. Solid liquid equilibrium, liquid vapor equilibrium, solid vapor equilibrium. So it's a matter of knowing that we establish equilibrium between molecules of a substance in one physical state, in a solid state maybe, and molecules of the same substance in another physical state. The substance here is in a solid state, but molecules of the same substance are existing in a different state of matter. So that is what we call a physical equilibrium. Now, I'm going to summarize one more thing before I go to drawing the diagrams. I'm going to summarize some of the definitions that we normally use here. But before I go to that, let's first look at the characteristics of a phase equilibrium. One, the equilibrium is attained in a closed system. Is attained in a closed system. 2, at equilibrium, the measurable properties of a system Yeah, well, we are on number 2, point number 2, where we were saying that at equilibrium, the measurable properties of a system become constant. And then we have another point whereby at equilibrium also, we have this property that at equilibrium, there is dynamic balance between two opposite processes. Dynamic balance. Change in balance between two opposite processes. So that one, we are going to also find out that in each of the 3 homogeneous physical states, that is the solid, liquid, and gas, where a substance exists is also known as a phase. So that one takes us to a set of definitions whereby we are going to look at a system phase component. We're going to look at these definitions. And the first definition, we're going to define what a system is. And I want you to know that a system is that part of universe, is part of universe, or part of the universe, okay? And the set of substances and energy associated with them that is being studied. Part of the universe. So we are looking at the system as part of the universe. The set of substances and energy associated with them that is being studied. So we are going to be studying the part of universe, the set of substances and energy associated with those substances. Basically, that is what we are going to be studying. Then after knowing this, we need to also know what we call a component. When we define a component, we define it as the pure substance in the system, pure substance in the system that defines part of composition, that defines part of composition of that system. So when we define the component of a system or the component in a system, it will always refer to that pure substance in the system that defines part of the composition of that very system. Then we shall look at what a phase is. So when we define a phase, we shall define a phase as a homogeneous right, and physically distinct part of the system physically distinct part of the system which is separated from other parts by a definite boundary. Simply that. Now, the main thing is here. A component is a pure substance within the system that defines a part of composition of that system, whereas a phase is a homogeneous and physically distinct part of the system separated from other parts by a definite boundary. For example, I wanted to first know that each of the three homogeneous states, that is the solid, liquid, and gas, each of these states in which a substance can exist is what we call a phase. For example, a mixture of gases, when we say this is oxygen, nitrogen, that is called one phase. That is a phase. A phase where homogeneous, homo means the same. So when we say homogeneous and physically distinct, but homogeneous itself has already meant the same. So when we have a mixture of gases, those ones will be considered as one phase. When we say a solution of something, when you mix substances to form a solution, that solution is also one phase. Okay? But when you get a certain saturated solution, and maybe when it is existing in presence of some solute, you have a saturated solution, you have a solute, now that one cannot be a one-phase thing, but instead a two-phase system. All right? So those are the cases that I can give. But then when it comes to a component, when you say like water and ethanol, when you say water and ethanol, these are two components. We have a component, water component, we have ethanol component, but one phase, all of them are in liquid state, one liquid phase. So these are two components. In other words, the pure substances that are defining this system are two. We have pure water component, we have pure ethanol component, but we have liquid phase. So they are two components here, but one phase. When you look at ice and water, these are two phases. When you look at ice and liquid water, these are two phases because you have solid, that is ice, we have water, that is liquid. So these are two different phases, but one component, the pure component, it is one pure component, rather it is one pure substance that exists within this system of two phases. So now when you have ice and water, we say that this one has two phases, but one component. As simple as that. Now, phase equilibria will always involve the study of the conditions, and the conditions we are talking about are the conditions of temperature, pressure, and concentration. Okay, so if I'm to define or if I'm to highlight further about phase equilibria, I'm going to say phase Equilibria, all right, involves the study of conditions, and those conditions are conditions of temperature, pressure, concentration, okay, under which different phases are in equilibrium, under which different phases are in equilibrium. For example, you may find that solid and liquid phase are in equilibrium under certain conditions. So that is what we are going to specifically be looked at. So, and we say that an equilibrium can only be achieved in a closed system. That is when the rate of movement of molecules from one phase to the other is exactly balanced by the opposite or by the opposing process. Now, we can note, basically here also, we can know that one liquid layer makes one phase, whether it is of pure substance or a mixture. But two liquid layers in contact show two phases. For example, a mixture of water and kerosene. There are two phases because there is a line of separation. When you look, those two substances are immiscible. When you look at water and kerosene, the moment you form this mixture will form a line, or what you call a liquid junction. And that one clearly shows that there are two phases because of that line which is introduced. But a mixture of gases will always make one phase because the system is homogeneous. All right? Okay, so, and another thing, maybe when you look at like an immiscible mixture of water, when you look at an immiscible mixture of water, tetrachloromethane, whereby iodine has been added. If we add iodine, now, these are three components: water component, tetrachloromethane component, iodine component. Two phases, and it has one boundary. Anyway, from here, I want us to specifically look at the phase diagrams. So let's move very fast and we look at the phase diagrams. Phase diagrams. Let me capture that in my next video, the phase diagrams.